Particular worksheet, you see the title says multiplying, so it'll seem pretty easy because we've already actually done how to simplify these, so this shouldn't really be too hard for you today. So if you want, what you can do, because you guys have calculators, you can do this two ways. If you're going to do it by hand, I recommend that you break down these radicands first so you'll have smaller numbers to work with. So that means simplifying that radicand, like the first one, you would simplify to 9 times 2. Okay, and then for the second one, this is times, and I'm going to put it in parentheses since we're actually times by the second one, a -6, and then you can break down the 12 to 4 times 3. So if you're going to not use the calculator, then I would recommend you to make these radicands smaller. So this would be 3 rad 2 here times, and we'll take the square root of 4 out, which is 2. Multiply that by the -6 on the outside, so that will give you -12 rad 3. Now the good thing about multiplying, different from adding and subtracting, you can multiply unlike radicands. So you can multiply radicands to radicands, the outside numbers that are on the outside to themselves as well. So when I multiply this, the outside numbers, -12 times 3 will give me what? -36. And then when I multiply the radicands together, rad 2 times rad 3 gives me rad 6. So again, you're just multiplying radicands to radicands, outside numbers to outside. I just simplified them before I did that. Okay, let's take a look at number 2. So I'm going to break down, and these numbers, really actually would be okay to multiply because 20 times 5 gives you the square root of 100. So that's okay because it comes out to be a perfect square. So again, you can do that. 20 times 5 is 100, so that's going to be 3 times the square root of 100. That's a perfect square. You take the square root of 100 out, which is 10, multiplied by the 3, and your answer is 30. Okay, so that was nice because it came out to be a perfect square. Again, radicands to radicands, that's just 21. You cannot simplify that any further, so you leave it as rad 21. Okay. For number 4, there's like an invisible 1 here. So 1 times 7 is 7. Okay, that'll be the square root of 4. Square root of 4 is 2. Multiply it by the 7 that's there, you're going to get what? 14. Okay. So this one will be a nice one to go ahead and multiply because it comes out to be a perfect square. What is 18 times 2? 36, and the square root of 36 is 6. Okay, so some of them, they actually come out to be perfect squares, like number 7. Really it's just a square root of 100, which is 10. 10 times 7, 70. All right. Now, let's just go ahead and leave number 6 like it is. So go ahead and multiply 35 times 5 because you can't really break down 35 anyway. So what is 35 times 5? How much? 175. All right, and 175 definitely has a perfect square in it, but let's just go ahead and use our calculators this time. So hit your y equals key, put in 175 divided by x squared. Okay, see what you get. All right, anybody found the factors on the calculator yet? Yes.
25. No, 25.
I mean, I just want the numbers that you get in your table. All right, you shouldn't say 25 though. What should it say? It should say 5 and 7. I just want exactly what you see on your calculator. So you should see 5 and 7. And then, of course, then you would multiply this 5 by the 5 that's on the outside. Okay, this -5 that's on the outside. So what is 5 times -5? -25 rad 7. Okay. All right, give me 1 second. Okay, so let's take a look at number 9. So again, you have calculators. If you want to make them big numbers, that's fine. But you know, the square root of 16 is 4. Okay, so it's up to you. You have a choice here. All right, you do have graphing calculators to use, but if you want to actually work it out, this would be -2 times the square root of 9 and 2. Okay, so this is going to become, when I take the square root of 9 out, is 3. I'm going to multiply it by the -2. That's going to give me -6 rad 2 times 4. Okay, because the square root of 16 is 4. So I just simply now multiply the -6 and the +4 together, and that's going to give me -24 rad 2. Now, if you did this on your calculator and actually got this big radican when you multiplied, I wouldn't do that because this is perfect. You definitely could. You'll still arrive at the same answer. Okay, so that's a choice you can take if you want the calculator to do all the work for you. Okay, it's there for you. All right, let's take a look at, I'm going to do some more of the odd numbers. So let's do number 15. All right, so I would like for someone to multiply 21 times 14. I cannot simplify that right now because there are no perfect square factors in 21 or 14. I'm going to go ahead and multiply my outside numbers and get -21, but can someone tell me what the radicand is? 294. All right, so hit your y equals key. We'll see if there are some perfect squares in that number. So when you hit y equals, you just put 294 divided by x squared in the calculator. Go to your table. Okay, we know how to find those pair of whole numbers. And then everything after that pair of whole numbers will be decimal numbers. Okay, so when you have it, let me know.
7 and 6, yeah.
7 and 6, all right. So if it's 7 and 6, that means the factors were 49 times 6. Because, if I really wanted to work this out, then I would have said 49 times 6. Because all you do is square this number that's in the x column. So those would have been the factors. But we didn't have to figure out. The calculator gave it to us. So since it's 7, and I have a -21 out here. So please multiply -21 times 7 for me. What does that give you? How much? -147, and then the rad 6 stays under the radical. Okay, so I simply took this 7 here, multiplied by the -21 that was on the outside. Okay,